Hi guys, welcome to the build video of this amazing little whoop. I named it the Insanity 75 because of the insane amount of power, agility and efficiency this little guy has. The components are in my previous video, check it out right here. I will show you how to put it together, how to set it up in Betaflight 4.2. Because the FC is inverted, we will have to remap the motors and tell the gyro that the board is upside down. If you're doing this for the first time, don't worry, just take your time, follow my steps, and we'll get through this together. You will need a few tools for this build: a pair of tweezers, a Phillips head screwdriver, a soldering iron. We're not going to be soldering anything on the board, it's for melting plastic only, and we'll get to that later. A hot glue gun, a sharp cutter knife, and some dental floss. Now, let's clean up our work area and start the build. I don't want to repeat the steps on the frame I am using right now. So this frame, one of my spare Mobula 6 frames, is going to be the frame I am going to show you how to do some of the steps, and it's going to be exactly the same on the Beta 75 frame, but I just want to make sure I don't have to redo anything that's already been done correctly. So first up, we start by melting down the FC standoffs. Those are located right here, and we're gonna melt them down so we don't have to use the rubber dampeners or screws anymore to keep the FC in place. This was a very smart mod from Mr Shutterbugs. I was a little bit concerned with losing the vibration damping, but I have to say I didn't feel a difference, and you save up to 0.45 grams. It doesn't sound like much, but it all adds up, and every gram matters on a little drone like this. I'm a little shaky because I get a really awkward setup right here, and normally this goes a whole lot easier, but there you go, it starts bending down, and that's about it. That's about what we need. Hope you can see that. We're just making a ridge at the end, so the FC will stay on without the need of the rubber. Once you start melting down the standoff and you see it melting and going down, you just press your soldering iron in ever so slightly to keep it going down, and then you get something like this. Next up, we're going to install the camera. Because I already installed it on the frame I am using, I am going to use the Mobula 6 frame once again, and another camera. This is the Betafpv M01 or something like that. It doesn't really matter, the shape is quite similar and the method of installing it is exactly the same. Because holding it down with dental floss can be a little fiddly, we're going to start out with it before the frame is filled up with the FC and the motors, just to make it a bit more easy. I put a very small dab of hot glue on the frame where I intend to put the camera. I want my battery toilet tanked, so like this, with the camera right there, so the battery doesn't get in the way of the camera and the battery will not shift forward in a crash or if you hit something. I'm going to put a little dab on the frame where I want to place my camera. I'm usually right-handed. Well, I'm actually always right-handed, so this way is a little difficult for me, but now the hard part, you have to align the camera with the center of the frame, and you have to get your tilt right. If you do not get it right the first time, don't worry. You can heat the glue up again with a hairdryer and make small adjustments. If you ever need to remove hot glue, don't peel it off cold, just heat it up a little and it'll come straight off. When the glue is set and the camera is in the right position, we're going to wire it down with some dental floss. If you only use hot glue, your camera will come loose every so many crashes and you will have to repeat the process. The dental floss makes it more durable. It weighs almost nothing. It's about 30 centimeters long, maybe a little bit longer, but doesn't matter. You can cut off the excess. And it weighs almost nothing. My scale can't even measure it, and it goes up to 2 digits after the decimal point. So there's no harm there. We're going to attach the floss to the frame and start making windings around the camera housing and the camera lens, like this. First off, attaching the wire to the frame. You're gonna need patience with this one. It's kind of like building a ship in a bottle. Not that I've ever built a ship in a bottle, but I suppose this is kind of resembling it. Just one more time. Just get that one through. Yeah. Oh yeah. Okay, so we attached it to the frame. Also, when you're gluing down your camera, make sure you got it right side up, because otherwise you're gonna have an inverted picture or off to the side or something like that, and you can't change it with a tiny hoop camera. So yeah, make sure you got it correctly. Okay. Just gonna try and feed that wire through there. Ever so gently. And you want it tight, but don't over tighten it yet. It's not tightening process will be at the end, so keep it snug, but don't really put a lot of force on it. I'm having so much fun right now. You can go around the lens like this. So this is what we get right now. It's better to start off with a longer piece of dental floss than coming to the conclusion you don't have enough. So make it long enough. The important part is to feed it. Just take the tip. Feed it through there and then through there. And now you got that part covered. You can actually tighten the whole thing down when you're pulling it. Do the same thing again. Feed it through again. And back there again. Alright. Now you can tighten that down. You can see these two ends being pulled together. So you tighten it up real good. You can feed it through again once more if you want to. Or you can just make a, how do you call it? A knob? No, not a knob. How do you call it? I have no idea. Just. Damn, what's the name? Tie a knob. Yeah, I think it is a knob. Just. There it is. Oh, come on. You make a knob so it doesn't come loose anymore. I'm just gonna call it a knob. I don't know if it's correct. I think it is. You can correct me in the comments. So, after you make sure it isn't going anywhere anymore, kind of looks like this now. You get the idea, don't you? Cut off any excess. And there you have it. This is what it looks like on the Beta 75 Pro frame, I believe it is. Now we're going to put the FC into the frame. I installed the board with the arrow. You can see the arrow right there. With the arrow towards the camera, but I flipped it upside down. This makes for a flat surface on the bottom of the quad. So this surface now becomes the bottom of the quad. It makes for an easily accessible USB port. I did have to cut a few pieces of plastic off the frame, one right here, and well, that's about it, I suppose. I had to shave off a little bit of this, and I had to bend the VTX antenna so it sticks out on top of the frame and not the bottom. You could desolder it. You could desolder it here and solder it back right here. But in this build guide, we are going to keep it as simple as possible and not solder anything. I have been flying it like this for a while now, and it works just fine. In my stage 2 video of this build, I will make it lighter, compare lighter Happymodel 19,000 kV motors with the Betafpv 22,000 kV motors, compare the very light HQ props with the Gemfan props, and we will be removing the motor mounts, and direct soldering the motors to the FC. And it does make a difference. With one setup, even without direct soldering the motors, I got up to 6.5 or even 7 minutes of flight time on the same 450 milliamp hour battery. If you don't want to miss that video, please subscribe and hit the notification bell. And if you're liking this video, hit that like button, of course. It really helps out my small channel. Now where were we? I now made the FC fit into the frame by cutting off this bit of plastic right there. To get the FC into the frame, you just I align one piece and then I bend open the frame and push it in. But before we do that, we have to connect the camera. It's right there, because otherwise you won't be able to reach it anymore. Then we install the motors. Now for the last motor, which is motor 1, I cut off just a little bit this corner right here because it hit the frame, and I could not cut the frame at that place because it would compromise its strength. So I left the frame alone and cut a bit of plastic on the motor plug. We got the motors in. I used only 2 screws per motor. Normally I would use all 3. You can leave one out just to save a little bit of weight. But I'm doing it because after I've done this video I am going to take it apart again and put other motors and props onto it, because I am testing a whole lot of configurations and settings to see what flies best. With the motors installed, we can all plug them in. Maybe to plug in motor 1 you will have to press out the FC board again just a little bit to get the plug in. Yeah, you have to. I couldn't really remember if I had to do that, so I pressed out the FC out of the frame, and now I should be able to get that in there, I hope. Otherwise we're going to be making a tricopter. Oh yeah, we get the RX antenna right here. I'm just going to feed it through one of those holes so it's not going to get caught in the propeller. You may notice I'm using the BT 2.0 connector. I use it on all my whoops. But if you get the PH2 connector, that's fine too. Just make sure you got the ones with the solid pins. The BT 2.0 is a little better in my opinion. You will notice battery sag a little bit less. You even get a little bit longer flight time with it. Yeah, that's optional. Next up are the props. I took these Gemfan 4-bladed props. You can find them on Betafpv and Banggood. I'll try to put links to all of the components in the description below. I don't think the Runcam Nano 3 version 1 is still out there, only the newer V2 version, and I don't have one. I believe the weight is the same, but it has a smaller field of view, so yeah. Back to the props. I just snipped off 2 blades of each prop, and you can cut the remaining part down or grind it down to make it look clean and kind of balanced. I did not balance these props, by the way. These flew fine. I set up my drone's props out, so I put them on like this. With your drone facing yourself like this. These are my front 2 props. And those are my back 2 props. Because props aren't meant to be put on motors from this direction, the top of this little hole sometimes is filled with some plastic residue. I used my pointy tweezers to grind it out just a little bit, just like this. So I could get them on a little bit more easy. Not too much, of course. You don't want your props spinning off when flying or crashing. That's what I do most of the time, crashing. I do some flying in between my crashing. Last thing to do is make sure your drone is off the ground, so the props can't touch anything and you can take off from a rock or something like that. This is a self-adhesive foam, and I've cut a piece that is exactly the size of the FC. Then I hollowed it out so the piece of foam doesn't insulate the FC. For me, one piece was barely enough, so I cut 2 and stuck them together. It also protects the board when you crash, so yeah. I weighed this one. It came in at, I believe, 0.1 grams on my scale, so it doesn't add much weight. I thought it would be more, but yeah, it's very light. Now we have completed building our drone. In part 2 of the video, I will show you how to set it up in Betaflight 4.2. At the end of the video, I will show you my pits, rates, filters, and JESC settings. I'm running bidirectional D-shot on it. You do not have to run bidirectional D-shot, but your filter settings and pit tuning will vary. So first, we're going to remap the motors. Maybe this is a good time to back up your settings, make a dump, and save it somewhere. If you ever want to revert to your previous setup, it will be easy to do so. Go into the CLI and type resource. Make a paper like this. This is your motor layout. We're gonna use this to write down our motor resources. Now, because we flipped the board, motor 1 and 3 are swapped and motor 2 and 4 are swapped. Make another piece of paper and swap the resources to the correct motor. 1 goes to motor 3 and vice versa, and 2 goes to motor 4 and vice versa. We're going to tell this to our FC. Type resource motor 1 with the correct resource, then press enter. Type resource motor 2 with the correct resource, then press enter. Type resource motor 3 with the correct resource and press enter. Type resource motor 4 with the correct resource and press enter. Now type save and it's going to reboot. To confirm we were successful, we go into the motor tab, connect the battery and test each motor. Betaflight warns you to take the props off, but this being a whoop, there is very little danger involved. If the right motors spin up when you ask them to, we're going to step 2. We're going to check if the motors spin up in the right direction. Take a piece of small electrical wire, spin up a motor ever so slightly. You can use arrow up or down on the keyboard to easily adjust the motor speed. Now insert the wire very gently into the props and see if it gets pushed out or gets sucked in. I want a props out config, so it has to be pushed out. On your piece of paper with the motor resources, you put an X if the direction of the motor is wrong, and you put a check mark if the direction of the motor is right. Now we know what to change in JESC. Open it up, connect the battery again, and click Read Setup. By the way, when you connect your FC to Betaflight or connect a battery, it will get hot. So I got a little USB fan blowing air over it to cool it down when having to plug my quad into my PC for longer periods of time. This is my JESC setup. First, we make sure motor direction is correct. So leave the ones that were correct, B. So leave the ones B that were correct and change the ones that were not correct. Now we click Flash All and choose the 48 kHz firmware. This takes away a bit of low-end power, but will increase your flight time. Once it's done flashing, you can choose to license all your ESCs. This will cost you $4 or $5, but I think it's worth it. So you can run bidirectional D-shot. It will give you better prop wash handling and some other advantages, but it's optional. You do not have to do this if you don't want to. If you've licensed all your ESCs, you can click Flash All Telemetry. Now you're set up to use bidirectional D-shot and we are done in JESC. Back to Betaflight. I will show you all of the settings you need with some screenshots to get bidirectional D-shot working properly, together with my pits, rates and filter settings. But first we will need to tell the gyro the board has been flipped, otherwise it will freak out when you try to take off. In the configuration tab, go to board and sensor alignment and type 180 next to roll. Now save. Go to the setup tab and move your quad. make sure accelerometer is on. Now when you move your quad, you should see the same movement on the screen. For some reason, this was not the case for me. I also had to turn the gyro to minus 90 degrees yaw to get it right. I have no idea why. So for the last settings, please follow the screenshots. You can try my rates or use your own, of course. And there, that's it. You're ready to fly this little beast. If you have any questions, leave them down in the comment section below, or just tell me how your build experience was and what you think of it. The stage 2 modding video is coming up soon with different motors, less weight, other props, and even longer flight times. So thank you for watching, guys, and happy flying!